So one of Nmap's best-known features is remote OS detection using TCP/IP stack fingerprinting. Nmap sends a series of TCP and UDP packets to the remote host and examines practically every bit of the responses. After performing dozens of tests, such as TCP/ISN sampling, TCP option support and ordering, IP ID sampling, and the initial window size check, Nmap compares the results to its Nmap OS-DB database of more than 2,600 known OS fingerprints and prints out the OS details if there's a match. Each fingerprint includes a free-form textual description of the OS and a classification which provides the vendor name, for example, Sun, underlying OS, that would be Solaris, OS generation, let's say 10, and device type, general purpose, router, switch, game console, whatever. OS detection is far more effective if at least one open and one closed TCP port are found. So let's see the OS detection in action. We have to use OS detection with one of the port detection techniques. So I use SynScan for this demo. The target system is Metasploitable. Let's choose top 100 ports to make the query faster, or just don't give any port. Let the Nmap scan top 1,000 ports. That won't take long. Put uppercase O for OS detection and hit Enter. Here is a result of OS detection. It's a general-purpose device and running Linux with a version between 2.6.9 and 2.6.33. If you would like Nmap to be more aggressive to have a more accurate result, you can use OS scan guess parameter with OS detection parameter. Now, let's scan a Windows system and try to find out the version of the OS. So here I have a Windows 8 virtual machine. I want to learn its IP address first. Open a command prompt, type ipconfig, and hit Enter. Now let's go to Kali and test if we can reach the Windows system. First, I'll ping the system. No, the system is not responding to the ping requests, or we cannot reach the system. So second, I perform an Nmap ping scan. We know how to do it, right? Type Nmap SN 172.16.99.171 and hit Enter. Yes, Nmap says the host is up. So we are able to reach the system. Now I want to scan the top 10 TCP ports of the system. I add the reason parameter to see the reasons of the results. All the ports we scanned are filtered because there are no responses from them. It's not good for us. So I add the OS detection to the latest Nmap query and rerun it. No, Nmap cannot find the OS details because it does not have a result set to probe or interrogate. I would like to open a port on the Windows system and reply the Nmap scans. In Windows 8 VM, I run the IIS, Internet Information Services Manager, and start to host the default website of IIS. Open a web browser and try to reach the website typing the IP address of the system into the address bar. Okay, web service is up. Let's test if I can reach the website from Kali. I go to Kali, open a browser, enter the IP address of the Windows 8 VM, and hit Enter. No, I cannot, and I think I know the reason. In Windows VM, let's look at the firewall if HTTP traffic is allowed. So I open the firewall. At the upper left corner, I click Allow an app or feature through Windows Firewall link. Click Change Settings, which needs to have admin privileges. Go to the end of the list. As I thought, HTTP services are not allowed. Check it and click OK to apply the changes. Now in a command prompt to see port 80, I run netstat an command. When I come back to Kali, I see that the page is loaded in the browser. That means Kali can reach port 80 of my Windows 8 VM. Now in Terminal Screen, I want to run SynScan for the Windows system's top 10 ports. Here we have an open port now. So let's reply the scan with OS detection option. Now we have the OS detection result. First, Nmap warns us about the results. It says the results may be unreliable because it couldn't find a closed port to probe. But anyway, Nmap makes it best. And here it says the operating system is one of them. Windows 2008, Windows 8.1, Windows 7, Windows Phone, or Windows Vista. Good job.